So we're going to look at what would happen if we were to create something called a sampling distribution today. So it's important that you recognize the difference between the sample and the population. Remember, the sample is the subset, the population is the group from which you're drawing. So let's imagine that we have a really small class, a class in which there are only 4 students. And on the test that we took prior to break, those 4 students had scores of 60, 70, 80, and 90. That would be my whole population because that's the whole group that I'm considering. So the distribution of the population scores, we'd have 60, 70, 80, and 90, and a 1 dot above each to indicate that there was one person that earned each of those scores. Problem number 2 says, take a sample. So now we're doing a subset of those 4 scores. In this case, 2 of those 4 scores. And we're going to find the mean of our sample. So which 2 scores? Well, we don't know. We can pick any 2 scores. So maybe I will choose 60 and 70. The mean of those 2 scores, 60 and 80. The mean of those 2 scores would be 70. Maybe your friend chooses 70 and 90. The mean of those 2 scores would be 80. If we think about all the different possible samples of size 2 that we could draw, we could pair 60 with 70, 60 with 80, and 60 with 90. We could pair 70 with 80, 70 with 90, or we could pair 80 with 90. And then find the average of each of those samples. So the average of each of those samples would be 65, 70, 75, 75, 80, and 85. If we were to make a dot plot of that, of all of those sample averages, that would be something called the sampling distribution of the sample averages for all samples with size 2. And it would look like what you see here. Now notice that if we were to find the mean of the original 4 numbers in our population, the mean of these 4 numbers, 60 plus 70 plus 80 plus 90 divided by 4, we would get 75. So we use this symbol when we're talking about the mean of the population. That's called a parameter. We use this symbol when we're talking about the mean of a sample. The X with the bar across the top is the mean of a sample. The Greek letter mu is the mean of the population. Now notice that that mean of the population would also be the mean of these numbers that we have here in our sampling distribution. In other words, if we were to add up all of these X bars and divide by 6, because there are 6 sample averages that are possible, we would get 75. When this occurs, we say that the sample average, X bar, is an unbiased estimator of the population average. Any numbers that come out of a sample are called statistics. Any numbers that come out of the population are called parameters. So, in the box that we have on the top of our next page in our notes packet, we could summarize. We had 3 learning targets to distinguish between what is called a parameter and a statistic. We created a sampling distribution using all the possible samples from a very small population, in this case a population of 4 things. And then we're going to make sure that as we go through here that we keep in mind the difference between the sample, the distribution of the population, those original 4 numbers, the distribution of one of those samples, so 60 and 70 or 60 and 80, 60 and 90 and so on, or the sampling distribution of a statistic, the distribution of all of the sample averages in this case. So learning target number 1, remember that a statistic is a number that comes from a sample. It's easy to remember because statistic and sample both start with the letter S. Likewise, parameter starts with the letter P, and so does population. So a number that describes a population is called a parameter. Notation here is important as well. We're going to use mu, the Greek letter mu, to represent the mean of a population, so that would be the parameter. We're going to use X bar to represent the mean of a sample, so that would be the statistic. You can write X bar in this box right here. The proportion of a population So if we're looking at the percentage of all white cars in Ankeny, that would be P. If we're talking about the proportion of a sample, that would be P hat. If we're talking about, the standard deviation of the sample, we'll call that S. And if we're talking about the standard deviation of the population, we'll call that the lowercase Greek letter sigma. So remember that a sampling distribution shows the statistic for all possible samples of a given size, and a population shows all of the values in the population itself. So I hope that helps with the first day of sampling distributions. Again, the keywords are population, sample, parameter, statistic, and sampling distribution. I believe there's a homework assignment posted in our online text. You can also attempt the check your understanding questions on the back of the note page there. I will send you the answer key as well as a blank copy of the note-taking guide.